David Smith here with another Flip Classroom math lesson. 3 tips before we start. Remember that you can adjust the playback speed if that helps you work through the video. You can also pause the video at any point to take notes or jot down questions. Lastly, you can turn on the captions so you can read my words go by on the screen. Today's topic covers series. Now, sequences so far, we've just been looking at how to write formulas to describe them and how to manipulate them and all that kind of stuff. And it's just a sequence of numbers that's either finite or infinite. Now, when we use the word series, what we're really thinking about is what is the sum, what is the total of all the numbers in the sequence. So, series and sums. A series is the sum of the terms in a sequence. Pretty simple, pretty straightforward. Just when you hear the word series, you should be thinking, I'm going to add those terms up and get a total. All right, so we have this thing called sigma notation, and it's kind of a core notation for this unit, so you do want to make sure you master it. Now, sigma is a Greek letter. It's this E thing, like that, with the little hooks on the top. It stands for sum. Okay, so when you see that, you know you're looking at the sum, in this case, the sum of a series. So let's take a look at some of the other variables I've put around here. Down here, I've said n equals 1. That means we're starting with our first term at 1. That's our first term. This here tells us that n ends at 5. So we're going from 1 to 5, and then we have our general term formula for the series of 3n minus 2. So what this is telling us to do is add up all the terms from 1 to 5 of this formula, okay? So we're just going to plug in our n's and make our terms and add them together. So before I do that, I want you to pause the video and do that. All right, so here's what I did over here. I just plugged in my n's in my general term formula, and I got for my first term 1, then 4, then 7, then 10, then 13. Added them up, got 35. Pretty straightforward math. The part here is you've just got to understand what this is. So this could be a prompt on a quiz, and I could just give you that, and the answer to this would be 35, like that. All right, here's what I want you to do. From 1 to 4, find the sum of the sequence that's given by minus 1 to the nth power times n squared, okay? Now, something to notice about this. If I have a negative number to a power, this is going to be negative one time, positive another, negative, positive. So this is going to make this function switch back and forth between negative and positive. So go ahead, pause the video, figure out what your terms are, add them up, and get a result. All right, let's see how you did. So I just did my plug-in. Negative 1 to the n is negative 1 to the first power, so that stays negative 1. 1 squared is still 1, so I have negative 1 times 1, I get negative 1. And so on as I go down. But notice how negative 1 squared becomes positive 1. So when we multiply that by 2 squared, which is 4, so this one goes positive. Then again, we have 3 squared, which is 9. Now negative 1 to the third is negative 1. So we go to negative 9, then we switch to positive 16, and we can keep going in that way. So we have the squares, the perfect squares of numbers, and now we're going to add them up. So these 4 numbers add up to 10. So the answer to this is 10. All right, let's do one more. Check this one out. We're going from 3 to 7, and our function here is minus 2 to the nth power. So I think, given the examples we've done already, you should have a pretty good feeling about how this one's going to go, but I want you to pause the video and calculate the sum of this series. All right, so I've got a negative number, and I'm raising it to a bigger and bigger power each time, so I know that my terms are going to flip between negative and positive and negative and positive. And so here's what I got for that. Going from 3, notice how we're starting at 3, not at 1, and we go up to 7 for that one. So I calculated all my terms, got them there, added them up. The sum of this one is minus 88. All right, one more example of these, and then we'll switch gears. So here you go, from 1 to 3 of 2n minus n squared. So you should be an old hand at this now, so go ahead, pause the video, calculate the sum of this series. Let's see how you did. First term, it's 2 times the 1 for my n. So 2 times 1 minus n squared, so 1 squared. So that's just 2 minus 1, so we get 1 for that. Second term, we get 0. Third term, we get minus 3. We're only going from 1 to 3. This is a pretty quick sum to make. 1 plus 0 minus 3 is minus 2. All right, this next process is a little more tricky because you do have to come up with the general term formula. So here's our prompt. Write in sigma notation. And so we know sigma is about sums, and that's confirmed by the fact that we have these pluses in here. We're not separating our terms with commas. We're actually putting a plus in there. This implies that we're adding all these things up. So the sum of this would be pretty easy to calculate. We could just do that on a calculator, but we're being asked to put it in sigma notation. So the first thing is we need to figure out the general term formula. Now this is similar to a problem we did 2 lessons ago. So why don't you pause the video and see if you can figure out what's going on. I'll give you a nudge. If you'll notice, we're adding 8 each time. Boom, boom, boom. So that's pretty straightforward. We know it's an arithmetic sequence because we're just adding a difference, a same number to each term. But we have to articulate this sequence in terms of n. So think about what's happening. All right, let's take a look at this. What I realize is that because I'm adding 8s every time, I just need to come up with a way to express that so I can put in my n instead of my different little terms in here. So what we're doing, first term is minus 3 plus 0 times 8. Second term is minus 3 plus 1 times 8, which gives us 5. Third term is minus 3 plus 2 times 8, which gives us 13, and so on through 21 and 29. So now you could come up with a general term formula for that sequence. All right, just like we did before, what I did is I figured out how to get this thing to be 0 when I plug in my n. And my first term is minus 3, so I need this to be 0. But the term number is 1. So I do n minus 1 to 0 this out. So for the first term, I'm going to have minus 3 plus 8 times 0, which is just minus 3. For the second term, I'm going to have minus 3 plus 8 times 2 minus 1, which is 1 times 8. So I'm going to have my minus 8 plus 3, and that gives me my 5. And so this formula will work itself out and give us all the terms in our sequence. Now, it's nice to simplify with a little bit of algebra. So I did my distributive property on here. I got minus 3 plus 8n minus 8. And then I consolidated. We like to put our variables first. So I have 8n minus 11. So that's my general term formula for this. Now, what we want to do is use this to write it in sigma notation. So I think you should be able to do that given what we've done so far. Pause the video, give it a shot. All right, so here we go. We're running from 1 to 5. 1 to 5, we have 5 terms. And then we're using our formula right there, 8n minus 11. That's our general term formula. And check it out. Let's just test it. Let's just put in a 5 and see if we get 29 out. So 8 times 5 is 40 minus 11. Yeah, that's 29. So here is the general term formula for this sequence. Oops, I call this the general term formula. This is sigma notation for the sequence that I just erased. All right, here's another one. Minus 3 plus 6 minus 12 plus 24. So we've looked at a bunch of sequences that have these characteristics. So I want you to pause the video, analyze what's happening, and see if you could write this in sigma notation. Okay, the first thing to notice is that we're sort of doubling and switching signs. So we went from a 3 to a 6, that's some kind of multiply by 2, but we went from negative 3 to positive 6. Then we went from positive 6 to negative 12. So it's kind of like we're multiplying each term in our sequence by negative 2 to get to the next one. But a general term formula is not like a recursive formula. So we need to come up with that general term formula for the sequence. So pause the video and see if you can do that. All right, so here's the formula I came up with. I'm multiplying by negative 2 every time to get my next term. So negative 2 to the n, and I'm starting with minus 3 times negative 2 to the n. Now, think about that. There's something not quite right there that we can fix with the sigma notation. if you went, well, but the first term, we put a 1 in there. So this would be -3 times -2. So by this formula, the first term should be +6, but it's not, it's -3. Now we could change this formula to fix that, but there's another way to do it with sigma notation. So watch this. What if I do n equals 0 to n equals 3? So this way, I'm going to be able to start with an n equals 0 in my formula right there. So check it, let's finish this out. Here's my formula. So first I count from 0. So 2 to the 0, negative 2 to the 0 is just 1, so that gives me -3. Negative 2 to the 1 is -2 times -3 gives me +6. Negative 2 to the 2 is +4 times -3 gives me -12, and so on. So that last formula in the previous example could have been done a little differently by starting on 0 instead of starting on 1. So these are equivalent, and if I grade you, I'm going to give you the same amount of points as long as yours is correct. One last problem, okay? So here it is, 8, 12, 16, 20, ... So that's going to have an effect on our sigma notation. So first off, come up with the general term formula for this. And let's use that trick we used in the last one where we start with term 0. It makes it a little bit easier. Okay, so I'm just adding 4 each time. So I would just use my n as I go up in terms. This is going to go up by 1, 2, 3, etc. So it's going to increase the amount of 4s I'm adding to my starting number. So this is a good general term formula for this, but it doesn't work because it's like one term off. So what we can do is we'll put in our sigma notation here and go n equals 0. And so that means the first number we put in is 0, so that just goes to 0. So our first term is 8. Our second term, we put a 1 in for n, we get 12, and so on. Now, how would you handle the ... Okay, it goes on forever, it's infinite, so what would we put up here? We put the fancy infinity symbol, just like this. So this means the sum of the sequence as n goes from 0 to infinity of 8 plus 4n. Now, can you sum this? It's a good thinking question. Is there a number that answers that question? The answer is no. This one grows forever. So you can't create a calculation for that sum. Second question, do you think that we could have an infinite series that had a sum, that we could actually calculate the sum for it? Think about that for a minute and come back. Okay, so if you answered yes, you're right. And we'll get to that in a later lesson. Now that you've watched the video, take a minute to jot down notes or questions that you might have for our next class. You can also re-watch portions of the video that didn't sink in the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.